Hey guys, welcome to episode 13 of my Agrarian Skies Let's Play. This episode we are going to be building some redstone flux power generation capability for the base. So far to date we have steadfastly avoided doing anything non-magical, but I want to set up a ME, applied energistic system, because I'm getting really tired of organizing things with chests. So I'm going to do that. It's just going to save my time and save my sanity, unfortunately. I just have too many little components fiddling around. And also, I want to be able to run a few other, auto-processing, auto-crafting things, and because the crafting stuff is really taking up a lot of my time, and I'm not doing as many builds because of it. Anyway, I've decided I'm going to make a new tower over here. I made a new tower, yeah! Where I'm going to put my RF generation. So I've got this B-space barrel here filled with alumentum, which is being made in my little golem alumentum farm over here. Whoa, and I'm falling downstairs already too. My ability sometime to navigate is not so good. So you guys remember that from a few episodes ago. That's a B-space barrel. I got one here, I've got one downstairs at my Essentia distillery, and I've got obviously the primary one over there by the infernal furnace. So because I've got that, you probably already know I'm going to use steam power. Steam power is probably the cheapest and easiest thing to set up. Well, actually, maybe lava might be easier, come to think of it, but I've got a surplus of alumentum, and it's less lag than having to run like a gajillion crucibles, lava crucibles, or whatever, ex nihilo crucibles to generate lava. So we're going to go with this instead. You can see I've already kind of carved out some space here and put together kind of like what I think is going to be the markings of the systems and the tubes and stuff like that. I've got a bunch of stuff on me right now. Let's grab some tubes. I always call them tubes, but I know they're pipes. I just have like this fixation with calling everything tubes. I don't know why. Let's see. Here we go. Get some of that. Yeah. So, and I've got these are the nice cables, right? The redstone energy conduits. And I also have down here at the bottom, let's go visit that, a Rednet energy cell. I know, right? A little bit overkill. But hey, if you're gonna do something, if I'm gonna do something, I'm gonna do it big, because that's how I roll over here. I'm probably gonna need to get some bricks or something, because I can't hover, so I have to pillar everywhere. Yeah. Think about making that thermostatic harness or a jetpack or something. Probably the harness, because that's more magical, and I like magic. Let's see it go up here maybe. So first things first, I suppose. Let's just layer everything up, get all the wiring in place. I'll do the first couple bottom layers and then probably cut camera after you guys see how this is supposed to lay out. I'm going to put together Rednet cable system too as well, because one of the things that I definitely need to do is make sure that this thing isn't running all the time, because this creates a lot of lag. It's not really necessary. So I'm going to make sure that we only run when we are actually generating power, which will be kind of cool. Let's see. I'm going to have to add another brick over here, because these are only half blocks. Yeah, that's great. Already running into problems with this. But I should be able to mostly just walk on these things. So as you can tell, that is a lot. That's going to be a lot of engines here. I believe this tower is up to the ceiling all the way up there, 16. And so 16 by 4, it's going to be 64 of these steam engines, and therefore there's going to be about 5,100, I think, something like that, RF generation per tick off this. My only concern is whether or not I'm actually going to have enough water to feed all of these engines. You see, I'm going to try and run multiple fluid ducts up through the ceiling, and we'll get to that in a little bit. But really, it's going to be, now that we got this one in place, let's go and do all the tubing. So I think I have it set up like this. Yep. And then let's make sure I do this right. We'll wire one all the way up to the top here. But yeah, so it's going to be quite quite a lot of water that's going to be required in order to run this guy. I had looked into doing, what do you guys call that? The not Tinker's Construct, because it's actually a Steelworks, which is a mod add-on to Tinker's Construct that adds the high oven, and it's generally the quality of that mod is maybe not quite so good. It's not bad, it's okay, but there's a few things that probably in our version of Agrarian Skies that could be improved upon. They just don't work as good as they should, maybe, if that makes sense. And it's kind of unfortunate. And one of those things is the steam generation. The steam generation in that high oven is terrible. I tried a few different ways to get it to work, but the primary problem is essentially that as you pump water into it and steam comes out, it has the same limitation that all the other things do, which is the new item that gets put into the oven, the same as the smeltery, basically, gets added to the bottom, and the bottom is the first thing that gets pulled out of the tank with a drain. So what you'll find is as you are converting water into steam, if you keep adding water to it, and eventually the stupid thing just will fill up with water and there'll be no more steam being pulled out because the water is just taking, the steam gets trapped in there and the water just ends up at the bottom of the list to pull out. So I tried that. I was able to get it to work by doing two different things. The first one was just basically massively restricting the amount of water flow that goes through the high oven, so setting it to really low compared to the high oven's actual capacity, which meant that there was never enough, I'll have to get that one later. Let me get it now, actually. There was never enough water in the system to actually cause it to back up sufficiently. So that was, kind of helpful. And the other thing I was able to do is I was able to generate a redstone clock, which could manage the timing on putting the water into the system and then give it like a second to clear. But obviously that's like really inefficient, because who wants a steam producing system that's like only working on half cycles basically. That's just a waste of time. It's not even worth bothering. So I shelved that idea after messing around with it a lot, as just pretty much unworkable. Now I could have very easily gone and created a big reactor, because big reactors are like super ridiculously simple to make. But I decided against that too as well, because I'm just all like, even though it will take up less space, and they do look kind of cool, I have to admit they look pretty cool and the turbines look pretty sweet, it's just like a little bit too non-magic-y for my taste, and I'm going to try to really stick with the magic. Why is this not working? Huh, that's weird. There must be like something in the way. I found I'm using that lamp of the arcane lamp over here, and I find that the arcane lamp actually screws up the placement of the objects sometimes, because it creates these little glimmers of light on surfaces, and if you try to place an object where that's... No, this is really weird. There it goes. If you try to place an object that has a glimmer of light on it, and it's invisible, so you can't bloody see it, right? Then what ends up happening often is that, oh, that's weird, you'll end up with the object either like going off center or something, or, you know what I mean, like you'll place the brick in front of yourself instead of like where you wanted to place it. So I'm always looking for those glimmers of light, trying to fix it. It's okay, like if you break one, like you can break it just by punching it or using a pick or something like that. If you do that, it's generally fine. Alright, cool. We're getting pretty close to the top here, and as you can see, I've already kind of like placed some stuff, so I'll have to maneuver around these things. These are kind of like my marking blocks that I put down just to kind of see how this entire system is going to come together. But yeah, I'm already, what is that, halfway through now? Wow, I've almost got, you guys don't even want to know how many, wow. If I can even do this. Here we go. That's better. So I should be able to fit, as you can tell already, a ridiculous amount of steam engines on one of these lines. I've got capacity here that I've overbuilt this in terms of the amount of space that I've allocated. So I could add like another row of these guys, or 3 rows of these guys going down to the floor. And if I did that, I could raise the total RF generation to something like around 20,000. But I don't want to make like 200 and something steam engines. This is unnecessary. So I'm going to do this for now. And I'm going to wire up the other ones too, just so I've got the tubes in place. So just later on, actually maybe I'll just pull those ones off and put them up here. We'll see. We'll see how this works out. Or maybe I'll do one on this line and one on the other line. But I made 64 engines, so as you can tell, that's going to be quite a bit. How am I going to do this? All right. And yeah, so I'm going to put the rest of these guys together off camera, and then when we come back, we'll talk about. We'll try to wire them up with water and elementum and see how that goes. So I'll be back in a few minutes. Alright guys, I am back and I have finished wiring up this massive monstrosity of stuff. Whoa. So that is 64 steam dynamos going all the way up to the ceiling over here. I've got room for 256 if I wanted that many. I probably would do that though. If I add more, I'll probably just be another bank over here, because I can't imagine I'm going to need more than 10,000 RF per tick power. I don't plan on running laser drills, so I'd rather use arcane bores in the nether, or use the blood magic meteor call ritual for ores if I needed to. But yeah, so just to give you an idea of the resources that went into this, obviously you guys, item ducts and fluid ducts or whatever weren't very expensive, but each one of these, like 64 of these guys, I think it was something like 12 stacks of copper, 3 stacks of redstone, stack of silver, and maybe 2 stacks of iron, something like that, I think. Yeah, around those levels. So it was not too bad. The copper was really the most. Like 12 stacks of copper can be quite a lot, but I found that I still have stacks and stacks and stacks and stacks of copper left, and that's just from my automated sifting that's been going on since the beginning of the series. And so I thought, what a great way to use it. You'll also notice that I've wired up Rednet cable. I've got a wire tail lever right now. Since these guys' default state is low redstone signal, I've got that thing turned on, so that'll mean that these things will be off, because I want to test a couple things first. Anyway, let's go and finish up wiring this guy up. So first things first is this dude here needs a lever, I think. I always carry a bunch of levers with me because they're just so useful. So let's put a lever here and start him loading the system. One of the concerns I have is that with 64 engines, he won't be able to load them all very quickly. But what should happen, and I should probably do this, let's see, he's going to need a loop, otherwise he's going to stuff stuff. Although if he stuffed things, it's probably not too bad. I will loop it just because, and then I will put this on a dense mode. Okay. Yeah, I always get really nervous whenever there's like stuff coming out that for some reason like that doesn't get looped, but we'll see. Just idiosyncrasies with item ducts, they can be kind of strange sometimes. Anyway, I've got some aqueous accumulators. I've got 8, so my plan is basically to put them down and see how much. I think I'm going to run them like this, I think. Yeah, that makes the most sense. Or maybe like this. Nah, running them like this makes the most sense. Okay, I want to see how many it takes to run this many engines. It used to be like you could run, see, with Buildcraft, one combustion engine would run, you could run eight combustion engines off one aqueous accumulator, like pretty bloody easy. So that was like never really an issue. I don't know what it's like in Agrarian styes, and they may have upgraded these guys, they may have not upgraded these guys, I don't really know. So I figured, what the heck, I will look into it, and then I might as well just fill this whole thing with water. It'll look a little bit more aesthetically pleasing if I do that anyway. So I figured, oh, what the heck, I'll just, you know, give it a shot and see what happens. So yeah, they should be filling up these guys down here with water now. So let's go check on that before I go turn everything on. Okay. Get rid of that. Okay, so let's look at one of the bottom engines to see how this is coming along. Oh, geez, it's mostly full already. That one too. It's not that many millibuckets per second coming through, but it might actually be faster than it gets consumed by the steam engine. Let's see. I need to turn on the Elementum. Oh, I did already, so that's been going. Okay, so I should just be able to turn on the engines here. Let's see if the ones at the bottom have power, have fuel or not yet. It does. Okay, and they all turned on. That's amazing. And this guy is generating redstone energy like a madman. That should be 5100 RF per tick coming into this system now. Let's watch. Let's see if one of these guys runs out of steam or runs out of water. That's what I'm really curious about, is whether or not the water consumption remains steady, or whether or not it dips over time to a level where I need to add another aqueous accumulator or two to each line. Interesting. Anyway, I'm going to let that run for a bit while I go grab a PRC. I'm going to program the PRC to use this Rednet cable to shut off the signal to the resonant energy cell as soon as he gets up to somewhere around, oh, I don't know, mostly full, like maybe 90% or something like that. Wow, cool. That's working pretty good. I guess that's kind of okay. Maybe not. We'll see if this goes dry. I'll just let this run for a bit. Anyway, I'll be right back after I get my PRC. Okay, so I've got my controller, and also I've gone and added another roll of steam engines, steam dynamos down here, and wired them all up too as well. So I've discovered that through a little bit of testing that you need so each one of these primary lines down there has 16 dynamos on it, and it's being fed by two aqueous accumulators going to 32 dynamos, because you'll see I've got them kind of like situated in the corners here. So here's the fluid ducts, right? So there's row 1 of dynamos, row 2 of dynamos, that's 16 each, 32. Two aqueous accumulators is enough to keep that running. Anything less than that, and some of the dynamos towards the top will start turning off. They'll go on and off, they'll blink on and off, because they're just not getting enough water to turn into steam. And that's fine. And also I've noticed that it takes about 3 stacks, yeah, I'm trying to think, probably about 3 stacks of Elementum, or maybe about 6 stacks of Elementum to generate 50 million RF. So it's quite a lot, actually. It doesn't seem like it should be that much, but it is. But I've pretty much decimated my Elementum supply just stacking these things up, right? So that's 128 stacks of Elementum currently loaded into all of these engines. You see I've got 33 million RF in this energy cell, and they're all turned off because I got this lever turning them off. What I'm going to do is, let's get back here, I'm going to set up a simple set reset latch. So I should have a comparator on me. Did I actually get the bloody comparator or not? Does not look like I have the comparator on me. That's easy enough to fix though. So I don't know if you guys have ever used these latches before. You've probably noticed already from my videos that I use the Rednet controllers quite a bit, because they're quite handy for working with Rednet. Like everything that I'm doing I could do with vanilla, particularly like clocks and reset latches and things like that. Like you can do it with vanilla redstone. The problem is it would be like, you know, potentially really huge depending on what it is that you're trying to do. to build, so the footprint is quite large, and it's just like I'd rather use the Rednet controllers because they're just smaller. Let's see, let's put the comparator down here. Okay, great. So what should be next is we should have put some cable here to see what this is. Let's put the controller. How do I want to do this? What do I want to do? Probably want to put it like I want him to basically like feed off the same signal. So if I put him like that, and then I put it'll make sense in a second. I just don't want to split the output twice into two different variables because it's just annoying. That should work, and I should be able to break this connection here, I think. I don't know if it matters or not. Actually, let's use a different channel. I'll use orange. That's the way I'll do it. Okay, cool. Sorry, just like thinking out loud to myself about how I want to program this. That should work. Let's make sure everything is wired up correctly. Looks good. Okay, so, yep, okay, so first things first, we want to monitor the low state of the controller. So IO back orange is going to be the low state, and we're going to say equal, less than or equal to 1, and we're going to output that to variable 0. Okay, so that's going to look for basically the comparator outputting a redstone signal of 1 or less, and then it's going to put the value in there. And then we're going to do a greater than to monitor the high state, so greater than or equal. So IO back orange, constant 14, which is 15 I think is the highest signal. 14 should be like almost full. And we're going to output that to variable 1. Alright, and then the next part is just the SR latch, or reset. So let's find it. SR latch. And so the reset state is going to be variable 0. The set state is going to be variable 1. And it's going to be IO back white, the white channel. Okay? So basically what this should do, I should be able to turn this power off, or turn this lever off right here. So let's turn that off. And then these guys should all come back on. Yep, they did. Okay, so what should happen is when this guy's power gets to a certain level, and why is he not filling up? Probably because I've done something derpy. Let's see here. Yeah, that needs to be blue on the bottom. Also, I can probably break these connections. I don't want to send redstone signals to the controller. I probably don't need this anymore either up here. Okay, that's a little bit neater. So now he'll be filling up with juice now. So what should happen is when he gets to, I don't know, approximately 90-95% full, right? So about 45-46 million RF or something like that. The Rednet, the comparator should output a signal like around 14, and then the PRC in the back should find that basically and say, oh, okay, so this has been 14 has been reached, so we're going to set the variable, which is the output to the back on the white channel, which is going to be a redstone signal. I believe the default is 15, right? So hopefully this should shut off before it actually reaches 50 million RF. We'll see. I don't know, it's still going. Let's see how close it gets. There they go. Boom, they all turned off at about 47. You'll see power still going into the system. That's just because it's draining out of the dynamos. Pretty cool, huh? I like how they just all kind of like, bam, turned right off. Yeah, wow. And actually, that's a really good setting, it seems like, because they're going to slowly dribble the power in from the dynamos until it probably gets pretty close to about 49 million. But yeah, so that programming in the back there worked. And that's like a really, I mean, come on guys, this is like a really simple sort of thing to set up right here. These little little controllers are just like fantastic. They save so much space. Like you could do all of that basically with redstone comparators, and it's not necessarily difficult to do. It's just like the footprint for it would be, well, I wouldn't be able to fit it into this little building, that's for sure. I'm going to put a Tesseract on top of this guy, and then he's going to transmit power to my machines inside my base, or I'll run cable. Probably just run a Tesseract to my machines. That's the easiest way to do it, nice and wireless. Yeah, anyway, I hope you guys enjoyed this build. Hope you learned something. And if you liked it, leave me a comment, leave me a like, and I'll see you next episode. I think we'll probably work on something cool, like maybe some more golem automation. I've got an idea. I want to start redoing, now that I've got power, I want to start redoing things, which means I'm probably going to want to get rid of this this stuff up here. So this is like really compact and nice, and it works very well. It's very efficient. Very efficient technical design, and it's giving me a lot of resources, but I just kind of want to get rid of it. I'm going to replace it with something really derpy using golems, which will be completely inefficient, but probably look really cool, and I'm all about that. Anyway, I'll see you guys next time. Cheers.